Hello viewers, welcome to Immortal Knowledge, and this is our very first video on our channel, and I hope you will keep us motivated by subscribing and giving us a thumbs up so we can come up with more and more educational videos for you, and let us know your opinions in the comment section below. I'm Sidharth Rai, and I hope those watching this video are safe during the pandemic. In this video, I will be talking about support vector machine, so keep tight as I will be also talking about some interesting facts about it till the end. With the help of support vector machine, we can solve various machine learning problems which are supervised of the categories like regression and classification. And in this video, I will be also talking about some terms like support vectors, hyperplanes, margins, marginal planes, marginal distance, linear separable points, non-linear separable points, and kernels. We will also be going through some examples during this video. So let's begin then. SVM is a supervised classification method that separates data using hyperplanes. Got it? No issues. Watch these slides and I will be giving you a basic intuition about SVM in this video with these slides and some geometrical approach. Suppose you got data of circles and squares that needs to be classified in class A and class B. Now we can easily separate these shapes with the help of a line called hyperplane. We will be talking about how to create a hyperplane in upcoming videos, and here are just a basic intuition of the support vector machine. When SVM creates a hyperplane, on the other hand, it also creates two other margin lines that is parallel to the central hyperplane. These other two hyperplanes pass through the nearest one or 2 points on the data of both the classes. Now, when we add up the distance, the dA and dB, we get this marginal distance. So whenever we solve a classification problem, we always create a generalized model, and anything above the hyperplane is considered a positive point, and all the points below the hyperplane is considered a negative point. Now you might be thinking, why only a central hyperplane? Why it can't be this, 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 or this? Let us consider another example where hyperplane is considered with the same points of data. Our main aim should be to maximize this marginal plane, and if we compare both the cases, we can find that the marginal distance in the first case where the sum of the dA and dB is equal to d1, and in the second case also it's d2. And on close observation, we will find that d2 is much greater than d1, and hence we can say that the maximum the marginal distance, the more the model is considered generalized and expected to give less errors. So all these cases we discussed above were of the linear separable points. Now what if we have non-linear points, and if we plot a linear plane around these points, we will get errors that would be of accuracy less than or equal to 50%. So how to solve these kind of problems? Now, if we plot this in a YZ plane, a clear separation is visible and a hyperplane can be drawn. And when we transform back this line into its original plane, it maps a circular boundary. These transformations are called kernels, where we convert low dimensions into high dimensions. Like here, we converted a 2-dimensional plane to a 3-dimensional plane. We will also have a look at the pros and cons of the support vector machine model. And talking about the pros first, as we saw, it is useful for both linearly and non-linearly separable data. It is effective in high-dimensional spaces like 2D, 3D, 4D, or even 5D. Let me know in comments if you need videos on understanding a multi-dimensional approach on data points. It is also very effective where data has more number of columns than number of rows, or we can say that number of dimensions are greater than number of samples. This algorithm is also very memory efficient as it trains itself for a subset of data or support vectors, you could say. Now, talking about some cons of SVM. Choosing a right kernel could be an intensive task in the case of non-linear separable data, as we saw earlier in this video. It doesn't work as expected when classes are overlapping. In those cases, we use high regularization parameters, about which I will be discussing in our next video, where I will also be giving a deeper explanation on SVM, and I will be also talking about some more points like kernels, gamma, margins, and we will also be doing some hands-on coding practices